Okay, good morning everyone. So now we're going to discuss lesson number 4, the nature of light. Okay, so here are some overview about our discussion. Light. What is a light? Light is a form of energy that brings forth the sensation of sight in our eyes. So that is the reason why we can see. So the path of light is always a straight line. And this straight line is called as the ray of light. So we have different characteristic of light. It could be absorbed, transmitted, refracted, reflected, dispersed, or scattered. So different characteristic of light can be observed in also different matter or medium. And lastly, light could travel and react into different matters. Nature of light. We have four theories about the nature of light. We have corpuscular theory, wave theory, electromagnetic theory, and quantum theory. The first theory is wave theory and was discovered by Christian Huygens. He is a Dutch scientist in the 17th century state that light is emitted in a series of waves that spreads out from light source in all direction. So these waves are not affected by the gravity. Furthermore, he disagreed with the Isaac Newton theory and said that the light travels from air to water will decrease the speed and vice versa. So Huygens was proved later to be correct. In addition, according to him, light is a longitudinal wave propagating in all directions at a constant velocity in a homogeneous medium. So therefore, in the study of Christian Huygens, light is a wave, and wave under longitudinal properties or longitudinal wave that travels at a constant velocity once it travels in a homogeneous medium. So the propagation of light in a vacuum is explained by assuming the presence of a hypothetical medium called ether. Okay, so on our previous discussion, ether was first introduced by Aristotle, and that is the fifth element. So he also suggests that each color of light has a different wavelength. So this is the longitudinal wave. So longitudinal wave are those kind of wave which the particle of the medium moves parallel to the propagation of the wave. So what are the example of longitudinal wave? That is a sound wave. Okay, so this is an image that shows the longitudinal wave. So this one, it shows the different wavelength of each color. So we know visible light consists of the Roy wave, red, orange, yellow, green, blue, indigo, and violet. So each color consists of different wavelength. So red having the largest wavelength and violet having the least of the wavelength. Okay, so if we have a red color, the wavelength is much larger than any of the color within the Roy-G-Biv. Okay, so after the wave theory of Christian Huygens, we have corpuscular theory. So the corpuscular theory was introduced by Isaac Newton in the 17th century. According to him, light is emitted by a luminous object consists of a tiny particle of matter, and he called it corpuscles. So when corpuscles hits the surface, each particle is being reflected. So in contrast with the study of Christian Huygens, according to him, light is a wave, and Isaac Newton, light is a tiny particle, and he named it corpuscles. Though that light travel from air into water, it will increase the speed, while light entering water will decreases the speed. So in addition, once this tiny particle travel from different medium, uh, water to air, air to water, it can changes its velocity. It's either increase or decrease. So this video clip shows the corpuscles that came from the sun, candle, and then flashlight. Okay, so this this image shows the corpuscles that travels from air and then in a solid particle. So once the particle changes, or this tiny particle changes its medium, okay, it either decreases or increases its velocity. In addition, this is how Newton created the corpuscular theory, and he performed a prism experiment. So Newton's particle theory by using a white light and then a prism. So he proposed it in the mid 1660s. So he had a source of white light that contained all the colors of the spectrum. So once the white light travels within the pinhole, and then it hits the prism, all the colors within the white light has been scattered. Okay, so he concluded that white light, or known as the visible light, contain all the color, which is the spectrum of colors, RGB. So on the other way around, color can be mixed together to have a white light. So objects appear colored because they are reflect, scattered, or transmitted that color, that color while absorbing others. For example, if we have a red apple, so we can see it is red because all of the colors of the spectrums are being absorbed, and the red color are being reflected. Sorry, it will become reflected. That's why we see the apple color red, because the only red color is being reflected. Okay. After the corpuscular theory is electromagnetic theory, and it was discovered in 19th century by James Maxwell. So he proposed that light wave do not require a medium for transmission. So in contradict with the study of Huygens and Isaac Newton, that must have a medium like air, solid, and liquid. According to him, light wave doesn't need any medium for transmission. So light wave possesses a electrical and magnetic properties that can travel through a vacuum. So the light waves are part of a larger family of electromagnetic waves that make up the electromagnetic spectrum. So this is the electromagnetic spectrum that are listed from according to their wavelength. Okay, so from radio waves, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray have from largest wavelength to least wavelength. We have here the radio wave that can be used in broadcasting and television. In microwaves, we use it for telephone, radar, and for cooking. Infrared, those are for transmits heat, suns, fires, and radiators. And we have here the visible light. Okay, visible light came from the sun or sun ray, and this visible light have a Roy-G-Biv color spectrum that makes things able to be seen. Okay, so that is only light wave that can help us to see things. And then after that, we have ultraviolet. Ultraviolet can be absorbed by skin, and it is used in fluorescent tubes. Next is the X-ray. So we know X-ray can be used for medical purposes. Okay? And then lastly, that have uh, least wavelength. Okay? Least wavelength is the gamma ray. Okay. This gamma ray is used in medicine for killing cancer cells. So in addition, electromagnetic theory, it proposed that light is a transverse wave having electrical and magnetic properties. So in addition, light as a transverse wave can propagate in a vacuum space, hence no hypothetical ether required. So this is an image that shows longitudinal wave comparison with the longitudinal and transverse wave. So what is transverse wave? Transverse wave are those waves in which particle of the medium move perpendicular to the direction of the propagation of the waves. Okay? Unlike longitudinal wave, it moves parallel. Transverse wave, it moves perpendicular. Okay? Next is the quantum theory. So quantum theory was discovered by Max Planck. He is a German scientist in the year 9 uh, in 1900s. So he stated that light waves travel as separate packets of energy called quanta, and later on it was introduced by Albert Einstein known as photons. So quantum theory is a merged subject or of corpuscular wave and electromagnetic theories together. So Max Planck summarizes all the theories and then put it to his study, quantum theory. According to this theory, light is emitted in discrete packets of energy called quanta, known as the quantum. And then later on, Albert Einstein referred it to as photon. So experiment shows that light has a dual nature. It could be a particle and a wave. Okay, so ascribing either the wave characteristic or particle characteristic depends on which property of light is being explained. Okay, so overall, light could be wave or particles. Light could have a characteristic of a wave that can travel through space or vacuum. Light could be a photon or particles. So now let's proceed to the second part of our week number 4, which is the speed of light. Okay, speed of light. The first scientist who studied the speed of light or measured the speed of light is known as our well-known scientist, which is Galileo Galilei. So he's the first scientist that was able to measure the speed of light. So he did this by measuring the time it took for the light to travel the distance between two hilltops that were miles off. Okay. In his experiment, Galileo turns his flashlight on and start his clock. So his assistant Massimo hold mirror which reflects the light back to Galileo. When there's the light reflected from the mirror, he stopped his experiment. After all, in his experiment, he concluded that it was light speed was too short for him to measure. Okay, so the time was too short and the distance was not long enough to enable Galileo to accurately determine the speed of light. So he merely concluded that light must have been traveling very fast. But that study or that experiment give an idea how fast the light is. So next, there is a French physicist named Leon Foucault. He conducted an experiment and came up with a value of 299,796 kilometer per second as the speed of light. So working on the method of Foucault, Albert Michelson began experimenting on the speed of light in the year 1879. So he used a precise device known as Session clock, and from his experiment, he have an he have a measurement that light could travel about 299,792.45 meter per seconds. Next is the geometric optics. So geometrical optics is a branch of optics where light could is described by rays. So here in geometrical optics, we're going to discuss the different properties or nature of light under rays. So light rays are conceived as geometrical lines originating from the source, extending to the different media and being revealed by a detector. Detector, it's either a naked eye or a reflection. So their direction account for paths along which light flows. To begin, the reflection of light occurs whenever a ray of light falls on a smooth, polished surface and bounce back. In other words, the ray of light approaching any surfaces result to the reflection of light. So as you can see here in our image, any light known as the incident ray will fall on a smooth surface. So once we have a smooth surface, there must be an equal uh, reflected ray. Okay, so incident ray and reflected ray must have an equal uh, measurement. These are examples of reflection. Okay, so we see our hand's reflection in a clear water or river or lake. Also, this one we can see clearly the reflection of the mountain within the lake. So once the light hits, okay, once the light hits the mountain or the hand, it will be reflected as the reflected ray would have an amount of equal amount dun sa incident and reflected ray. So next is the plane mirror. The plane mirror has a flat reflecting surface without any inward or outward curve. So a ray of light falling on a plane mirror is reflected at the same angle as the angle of incidence. So they have the same, the image and the object have same distance and same size. So it is virtual, upright. As a result, the image formed by the mirror is sharp and undistorted. This image is not real but virtual because of the image formed behind the mirror by extending the diverging reflected rays backward. So this is the image formed by the plane mirror. As we can see, if we stand at the front of the mirror, we saw an image. Okay, this image is a real image, no? With same height, same appearance because of the characteristic of a plane mirror, which is a flat, and the image is created beyond or beyond the at the back of the mirror. This is an example of image formed on a plane mirror. Okay, so that is, they have the same size and then it is upright and a real image. So we have two types of lenses. We have convex lens and concave lenses. So what is the difference? A convex lens is thicker at the center than the edges. So it is called converging. Once the light travels from a convex lens, the light are converging. The other one is concave lenses. They are thinner at the thinner. The concave lens is thinner and then center than the edge. So it is called diverging. So if ever a light passes through a concave lenses, the light is diverging. Okay? Okay, so what are the difference between the concave and convex? Convex mirror, or simply put, a curved mirror, is a mirror in which the reflective surfaces bulge toward the light source. Okay, that's why it have a middle middle part as a thicker compared to the edges. The surface of the mirror can be convex, which means bulging outward, or concave, bulging inward. A convex mirror reflects the light outward and is therefore not used to focus a light. Concave mirror, a concave mirror or converging mirror has a reflecting surface that is recessed inward or away from the incident light. That's why its middle part is thinner compared than the edges. So concave mirror reflects light inward on the focal point. So they use to focus lights. Here are the uh, uses of concave lenses. So we use concave lenses in a flashlight as well as the headlight in any vehicle. So we use concave for us to magnify the light, okay, magnify the image. Convex, since here are the common use of convex. We use convex lenses to focus the light. Okay, so we use the convex lenses in a magnifying glass or in a telescope that use to uh, magnify the small objects. Next, we have refraction of lights. So refraction of light is the bending of light. It also happens when sound, water, and other waves passes from one transparent substances to another. So this bending of refraction makes it possible for us to have lenses, magnifying glass, prisms, and rainbows. So these are the examples of refraction. So we can see if we put a pencil in a glass full of water, we observe that the pencil seems like to bend. Why? Because once the light passes through one matter to another matter or medium, the light the light will be refracted or it will bend. So the image appears to bend also. This is the example of refraction of light. So as we can see, the first time light travels in the air and then it travels in a solid medium, the light bended. Here are some common example of the reflected rays. Okay, um, we use this for we can observe this when we are hunting fishes. It is the reason why we have rainbows and also the reason why we have mirage. Okay. Okay, so that's all. Thank you.